So this will be a quick example. We're going to graph the polynomial function. So we're going to graph this, and it's going to be pretty easy. It's going to be very easy. We're just going to plug in some numbers and then plot them. Okay? Hey, that's not going to be bad at all. I can do that I can do it right now. You don't need to do this. I'll do the example anyway. I'll do it anyway. Okay, so what do I want to do? I want to make a table of values. So step one, actually, this is the biggest degree. I'm going to rewrite this just because I like it to be in standard form. So this one will come first. So positive x to the fifth, and then this one next. So that one's done. Minus 3x to the fourth. There we go. And then the regular x, and then the minus 4. Okay, that's just my preference. And I'm going to have x values. Okay. And then I'm going to have f of x values. That's my y. That's my y coordinate. And then, so let's see what happens. Actually, and I'm going to erase this part because they're going to be ordered pairs. So, if I plug in, and I'm going to plug in the same things every time. So, -2, -1, 0. Some people who had my class for Algebra 1, they're like, oh, I remember this. Maybe not. Actually, they probably don't. 1 and 2. Maybe the ones from last year. I'm plugging in -2 all the way up to +2. And I could just do that in my calculator. I'll just do it in my calculator. Do it all once in my calculator. So x to the fifth. Oh, how do I do that? There's the x to the y button on your calculator, maybe, for some calculators. That's how you would do that. So I would say, well, I want to plug in -2, so I put -2, and then I do the exponent of 5, and then that gives me -32, but that's not what I put there. So -32 minus, so minus, and then parentheses, 3 times x to the fourth. So that would be -2 to the fourth. Equals -80. I'll write out this stuff because, I mean, you don't have to write it out. You can do it all in your calculator, but I'm going to write it out. So I have, I'll do it in blue. -2 to the fifth, that's a -32. Minus 3 times, well, -2 to the fourth, that's just 16. 2, or -2 to the fourth. Yep. That's positive 16, right? Plus 2 times, so I'm writing out just so I don't get confused. And then 2 times, what, -2? Yeah. And then minus 4. So what does this come out to be? I can just, well, I'll do this part. It's just simplifying. -32. I mean, it takes a lot of work, but hopefully you have a calculator, so you can do it on the calculator. Times 3 equals minus 48. No, that's minus 4, and then minus 4, right? Because that plus a negative becomes a subtraction. Then I could just do all of this in my calculator. 32 negative minus 48 minus 4 minus 4 equals -88. Great. Wow, that's a lot. I'm not going to be able to put that on my graph, but that's okay. And then I'll plug in a -1. What happens when I plug in a -1? I'll alternate colors. So -1 to the fifth is just -1. Minus 3 times -1 to the fourth, that's +1. Plus 2 times -1 minus 4. And that's just the same thing as -1 minus 3 minus 2 minus 4. So what is that? Oh, these are all negatives, so I can just add them all up. That would be -10. So I do that. And that's pretty easy. And then when I plug in 0, this is the easiest part. When I plug in 0, all of those go away, right? I just get 0 minus 3 times 0, which is 0, plus 2 times 0, minus 4. So I get 0, comma, -4, right? Because that goes away, that goes away, that goes away. And that's my y-intercept. Look, it's the y-intercept. You know it's the y-intercept because the x is 0. So that one's an easy one to do. And then x to the fifth, well, if I'm plugging in 1, that's 1 to the fifth is just 1, minus 3 times 1, plus 2 times 1 minus 4. So that's just 1 minus 3 plus 2 minus 4. So what do I get? I get 1 minus 3 is negative 2. And plus 2 is 0. And then negative 4. Oh, negative 4. What? What? We got two of the same things there? It appears that way. Okay. And then the last one, I plug in a positive 2. 2 to the 5th, that's 32. Minus 3 times 2 to the 4th was 16. Plus 2 times, well, positive 2 minus 4. So that's 32 minus 3 times 16 equals 48. Plus 4 minus 4. So that cancels out, really. But I can just add it from left to right. So I will do that. And then what do I get? I get negative 16. I might not be able to graph that. But let's think about the end behavior. What is this? Ooh, it's x to the 5th. So it's an odd function. So what should it look like? I'm just going to sketch it real quick. What should this look like? Something, and it's a positive. So it should look, something happens. Should look like that. So we'll see. Let's try it out. And I'm going to just plot these points. It's very simple. I'm going to do a rough sketch for this. So I'm not going to do this exactly, but at negative 2, 1, 2, I'm way, way, way far down here. Something way, way, way down there. I'm not even going to plot it. Negative 1, negative 10. So at negative 1, I go down to negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, close, but no cigar. So that's that point. Very easy. 0 comma negative 4. 0, that means I don't move at all. And then I go down 4. 1, 2, 3, 4. Now I'm just plotting the ones I can. If they're way off my graph, I'm not going to plot them. And then 1 comma negative 4. Oh. And then 2 comma negative 16. 2, 1, 2, comma negative 16. Well, that's way down here. Wait a minute, and you're thinking like, what? It looks like that. Well, if I plot maybe something, let's plot 10. It should give me something way up there. Because it should look like this, so I'm going to check it. I'm going to plug something over here. I'll plug in a positive 10 and see what happens. So I'm going to plug in one more. 10, comma, whatever. Alright, let's see. So I get something like this. That's, okay, well that's 100,000 minus 30,000 plus 20 minus 4. What? Minus 4, there. So then what happens? What happens? What is this? 100,000, 1, 2, 3, minus 30,000, minus 30, 1, 2, 3, thousand, plus 20, minus 4, minus 4. Yep, this gives me 70,016. So that's enormous. 70,000, that's not a 10. 016. Okay, so that's way, 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 way up here. So it does indeed look like that. And, I mean, hopefully we understand that. You're not going to get too many of these problems, so even though it takes a little bit, it should be fairly straightforward. What were the steps? Well, I wrote it in standard form, and I plugged in these numbers. You can plug in actually any numbers that you want. I just wanted to plug in enough so I could see what was happening. And then look at the end behavior. Remember, if it's odd exponent, it's going to look like it's going to have either a positive slope like this. See, positive slope, or negative looking slope. So it would be going the other way. It doesn't really matter what happens in the middle too much. I mean, we don't care for if we're talking about end behavior. I'm talking too much in this video. I'm going to be done. Goodbye.